Our first lesson covering exponents, factoring, and quadratics is our walkthrough worksheet, so make sure you're on the right set of notes before we begin. And this is a concept that I know you've seen a lot of in Algebra 2, but we just have to see it one more time. So when we are combining terms because of their exponent rules, we're going to first look at x squared times x to the third. Now what that truly means is x squared is 2x's, and x to the third is 3 more x's. So you could write it out the long way and then count them up and say that's really x to the 5th power. Or, someone I'm sure can tell me the shortcut, when you multiply the two bases together, you're supposed to add the exponents. So if you'd like to write out the next problem the long way, go right ahead. I'm just going to use my shortcut and say 6 plus 3 gives me x to the 9th. Now for part C, be careful, because now we've got coefficients. So the 3 and the 4 coefficients are still going to be 3 times 4, which is 12. And then x to the 5th times x to the 4th. If we add those together, we get x to the 9th. And then something to remember, anything to the 0 power is always equal to a 1. I don't care what it is, anything to the 0 power is a 1. So the rule is, when you multiply terms, you add the exponents, but multiply the coefficients. So exponent rules do not apply to coefficients, only to exponents. Now on example A on the next section, x to the 4th power to the 3rd power really means you have 3 groups of x to the 4th. So you've got 1, 2, 3, 4 4 x's, and then 1, 2, 3, 4 more x's, and then 1, 2, 3, 4 more x's. Ooh. So if I go ahead and try to count those up, I end up with x to the 12th power. Now hopefully you remember the rule for a shortcut, because I don't want to have to write all those out. And whenever you have a power taken to another power, you really just multiply those powers together. So using my shortcut here for x to the 3rd to the 5th power, because I don't feel like writing all those out, I get x to the 15th. Now be careful here. When you have 3x to the 4th power all taken to the 3rd power, you've still got 3 taken to the 3rd power. So think about that as a separate kind of a problem, times x to the 4th to the 3rd power. So 3 to the 3rd power, either in your brain or on your calculator, is actually a 27, and then we still have x to the 12th. Now be careful when you have 2x minus 5 squared. This is a binomial squared, and the ACT loves to give you this problem because half of the children forget it's a FOIL problem. So you really end up with 4x squared minus 10x, and then there's another minus 10x, and then plus 25. We did that by doing first, outer, inner, and then last. So you finally end up with 4x squared minus 20x plus 25. Many children just think about distributing the squared, which is not at all how you do that problem. So when you have a power taken to a power, you multiply the powers, or the exponents. Okay, now this next problem, x to the 4th divided by x squared, that means we have 4 x's up top, and we've got 2 x's on the bottom. So back when we were first teaching this to you in Algebra 1, we'd show you that 2 of the x's canceled on top and bottom, and that just left you with x squared. Well, I'm hoping someone remembers the rule, x to the 4th over x squared. If you were to just subtract those exponents, you would get the same answer. So using my shortcut here on letter B, x to the 8th divided by x to the 5th is going to leave you with x to the 3rd up top. Now be careful in this next problem, because we've got coefficients, so 4 over 2 is going to be a totally separate problem, and that's just going to leave us with a coefficient of 2, because 4 divided by 2 is 2. Now for the x to the 3rd over the x to the 7th, I know when I subtract them, I end up with a negative 4, and negative exponents always end up on the bottom. And some of you think of this as saying there's 4 more x's on the bottom than on the top. That's a fine way to do it. And then for the y's, we've got y to the 6th over y to the 3rd. And this time there's 3 more x's on the top than on the bottom, and that's why you have y to the third on the top. So it was a little more complicated than just your typical division problem. So when you divide exponents, you subtract. So 2 to the third power, if you did that on your calculator or in your head, it's an 8. 2 to the second power is a 4. 2 to the first power is a 2. Anything to the 0 power is a 1. Now if I take 2 and I take it to the negative first power, instead of it being a 2, because it's a negative, I actually need to take that and I need to flip it to the bottom. So I end up with 1 over 2. Same thing with 2 to the negative 2. It's not a 4. I need to flip them to the bottom and make it 1 over 4. And then 2 to the negative 3 is not 8. It's going to be 1 over 8. So the rule there is that when you have a negative exponent, you need to flip that base to the other side of the fraction. Okay, this next section should take you a split second. Anything to the 0 power is 1. So you're a 1, you're a 1, you're a 1, and you're a 1. Easy. Alright, let's talk about fixing these negative exponents. And remember the rule is we need to flip them to make the exponent positive. Now be careful here on number 1. The base who has a negative exponent is really only the x. So the 4 is going to stay in the numerator, and only the x is going to flip to the denominator. Okay, here on number 2, we've got a coefficient of 5 over negative 10. Be very careful here. That just means our coefficient is a negative 1/2. It doesn't flip anything because they weren't exponents, they were just coefficients. Now, on this next part, x squared over x to the negative 3, you could either flip x to the negative 3 up to the top, or you could just go ahead and subtract. 2 minus a negative 3 is a positive 5. So we're going to end up with x to the positive 5 up in the numerator. Now this answer looks really gross the way it's looking right now, so I'm going to clean it up, and I'm going to say negative x to the 5th over 2. That's a great answer. I'm going to go ahead and distribute the negative 2 to everybody in number 3. We have 6 to the negative 2 times x to the negative 6. But remember, anybody who's negative needs to flip to the bottom for exponents. So both of these guys are going to flip to the bottom. And since there is nothing left in my numerator, I'm going to put a 1 as a placeholder. And I could write 6 squared times x to the 6th, but the ACT would like you to go ahead and simplify 6 squared and create 1 over 36 x to the 6th. The thing about, exponents is that sometimes you can get the answer really, really fast in your head without showing a bunch of steps, and some of us can't because we make mistakes. So you just do what's more comfortable for you.